Boom, excellent. Shh. Calm, calm, calm. We're going to talk about the homework, I promise. All right, we're just going to go through a couple examples real quick on a new unit. It's called related rates. Okay? It's not really a new unit. It's just a new application of derivatives. All right? So let me read this to you story time-wise. Okay? This weekend I was hanging up holiday lights.
Oh, God, this is real
Holiday lights on a 30-foot ladder. All right? I had it leaning against my house. So if you think about what my house might look like, I mean, imagine this, but much, much fancier. It's like a mansion. Okay? There it is, and there's like a door, and I got like one window up here. And then I had a ladder leaning against it like this, boom, and the ladder is 30 feet long. Okay? So I'm up there, I'm working hard, I'm hanging lights, I got all my little like clippy things and my rain spouts and everything. And then my son comes out, and he decides to play a joke, and he pulls this part away from the house like that. Okay, but still on the ground. So he's pulling it, Solani. He's pulling it along the ground, and as he does that, right, I'm going to be falling down on the side of the house. Does that make sense? Okay? So, let's check this out. I'm telling you that he is pulling it at a constant rate of 3 feet per second, which I just happen to know. All right? The question I'm asking you is, how fast am I falling down the side of the house? So, let's talk about a couple misconceptions that students usually have for this. You ready? Just because, y'all with me here? Just because this side, which I'm going to label B for right now, is being increased by 3 feet per second, right? Because he's pulling the ladder away from the house at 3 feet per second. That does not mean, you with me, David? You guys are just chit-chatting over there?
No.
Oh, Judy Kim. Oh, my goodness gracious. Just because side B is growing at 3 feet per second, that does not mean side A is growing at 3 feet per, or shrinking at 3 feet per second, okay? They don't have the same rates of change. And what's even worse is that B is changing at a constant rate, okay? B is growing at 3 feet. Every single second that goes by, B gets 3 feet bigger. A is not growing or shrinking at a constant rate. A is decreasing at different amounts at different times. Cool? So in a question like this, they will not just ask you this. How fast is the ladder falling? Because it's different for different times. They have to ask you at about a specific time. In this case, it's how fast is that ladder falling, specifically when the bottom is 18 feet from the house. Okay? So just a couple things that always happen with related rates questions. All right? Or steps that you should go through is first you should draw a picture, which I've done. It's like a work of art down here. Okay? Draw a picture. Label everything in your picture that is not changing. Okay, label all the constants. So the only thing in this picture that's not changing in this triangle is the 30-foot ladder. That's always 30 feet. Okay? But the base of that triangle is growing, and the side of the triangle is shrinking. It's decreasing. So I gave those variables. Okay? Secondly, you want to go through and try to find all the information that they're giving you. In this case, I know that the bottom of the ladder is growing at 3 feet per second. What that is the rate of change of B, okay? Which rate of change is synonymous for us with derivative. It's the derivative of B. But it's the derivative of B with respect to time. You know, normally we derive Y with respect to X. Okay? This is the derivative of B with respect to T. So this is what we know about that then. We know that dB dt is 3 feet per second. Okay, that's how fast B is growing. What are they asking me to find? The rate of what? The rate of change of A, which, Seneca, you are very correct, is dA over dt. They're giving me dB over dt. They're telling me how fast something's changing. And then they're asking me, hey, how fast is this other thing changing? Cool. So I like to write that out, put a question mark next to it, and put it in a box. That's your goal. That's what you want to find. That's when you know you're done. Okay? So that's why these are called related rates, by the way. They're going to give you rates of change of something or maybe multiple things and then ask you for the rate of change of something else. Okay? So anytime you want to find a variable, in this case dA dt, we need an equation with dA dt in it. So to get that, we're going to go back to our picture, which I'm going to erase this a little bit just to make it a little bit simpler, okay? So this is just a right triangle where this side again is 30, not changing. This side's B and this side's A. Okay? The equation that we're looking for here is an equation that's going to link A and B together, which hopefully everybody knows this should be easy, is the Pythagorean theorem at this point in time, okay? A squared plus B squared has to equal 30 squared. And the reason why we want an equation like this is because I don't really care what A and B are. I care what the rate of change of A is. So I have an equation that has A's and B's in it, but since I care what the rate of change of A is, guess what I'm going to do to this equation? Just guess. Oh, that's so enthusiastic. Excellent. Yeah, we're going to derive it. We are going to derive this equation, Mukti. Okay? Excellent. And when we derive it, we're not deriving it with respect to A or B or X or Y. We're deriving it with respect to time, because we know how fast B is changing with respect to time. Okay? Which means that when I derive it, A is not going to become 1 when you derive it. Okay? The derivative of A squared, you're going to do the power rule, so I think that's pretty basic, right? 2A. Oh, man. 2A. But then it's not just 2A. You have to multiply by the derivative of A with respect to time. So that means right after this is going to come a dA dt. It is implicit differentiation. That's the chain rule right there. So that's different than when we derived y equals x squared, right? Because when we derive y equals x squared, you're deriving that with respect to x. So when you do that, you get 2x times the derivative of x with respect to x. But dx over dx is just 1. So you don't write it. It's just 1. Okay? But when we're deriving with respect to a different variable, you're going to have a derivative. So d over dt is how we write it. And all that means is how fast is a changing with respect to time. Okay? Excellent. Thank you, AJ. So then what's the derivative of b squared going to be? 2b. There you go. 2b db dt. Cool. And that's going to equal the derivative of 900. What? The derivative of 900, which is 0. Okay. All right. So, again, our main goal here is to find dA dt. We've got 3 other variables up there. We have A, we have B, we have dB dt. Which of those do we know right now? We know dB dt is 3. We're going to plug that in. What else do we know? We know B is 18. Okay, that equals 0. There's a big plus right here. We don't know dA dt, and we're not supposed to know dA dt right now. That's what we want to know. So we're not going to be able to plug that in. The only variable left that we don't know is A. Okay? When that happens in a question like this, there must be some way for you to find out what A is. So go back up, read the problem again if you have to, take a look at your picture, go back to the original equation before you derived it. The only variables in that original equation are A and B. Okay? If you plug in 18 for B into our original equation right here, then the only variable we don't know is A. Okay? And that means we can solve that equation for A. And when you plug in 18, this happens to be a 3, 4, 5 triangle gang. Because 30, let's talk about this. Because 30 is, you can just do Pythagorean theorem as well. But because 30 is 5 times 6 and 18 is 3 times 6, A has to be 4 times 6, which is 24. Cool, but you can just do the Pythagorean theorem too. It really doesn't matter for that one. But it's 24. And now you can see the only thing we don't know now is dA dt, and we can solve for it. So when we put everything, I'm going to move it over here. We got that. So when we solve for dA dt, you were going to get, what's 6 times 18? 108, right? Yeah, why not? You're going to get negative 108 over 48, and 12 goes into both of those. So that's negative 9 over 4. And then you got to remember your units on there, and the units should match up with what the problem was already in, unless like someone's trying to trick you, which I'm not. So this is going to be in feet per second. Why should this be a negative number? Not because it's falling, but because it specifically is getting smaller. The rate of change is negative because it's getting smaller. Okay? You can notice here too, gang, if you were to plug in a different value for B, like if B was at a different time, we'd get a different answer for dA dt. Okay? All right.